Hello students, let us start a new topic, continuity and differentiability. First of all, we will deal with continuity and later on differentiability. Continuity. So by the word itself, continuity, we've already heard this word, continuity or continuous. When we say continuity or continuous, what does it mean? Something is going on and on without any interruption or stoppage. That means there is no break. So that means continuity or continuous. Now we will understand continuity of a function. So we have learned function. We write function as fx, say fx equal to y. So x is the domain, and we get for every x in the domain we have a unique y. So that is a function, and for every function we have to know that we can draw graphs. We can have a graph for every function, taking x as the x coordinate and the image of x, that is y, as the y coordinate in the Cartesian system. So let us understand what is continuity of function. Let us understand with the help of graph. Take a graph like this. Say this function is fx. It may be any function. It may be defined any way, but we just look at the graph only as of now. So you see that in this graph the graph is going like this without any break in. There is no break in the middle. It is flowing like this. And let us take another graph. Compare these two graphs. This is just a graph. Compare these two graphs. Now we see that in this graph, here there is a gap, and again it goes like this. So let's say this is a graph of a function gx. So there is difference between these two graphs. Here the graph is going on without any interruption, and here there is a interruption, or there is a break in the graph. So this kind of graph where there is no stoppage or there is no interruption, this kind of graph is said to be a continuous graph, while this is a discontinuous graph. Now when we draw this graph with a pen, we don't have to lift the pen. We just draw at one go. But then when we draw this graph, here we stop, we lift the pen, and then we again draw this. So at one go we cannot draw this graph. So this kind of function is a discontinuous graph. Now here it is continuous. This is as a whole continuous function. But here we see that is the function discontinuous everywhere. Now if we take for this interval, if we restrict the graph to this interval, then we see that in between this interval there is no stoppage or breakage. The graph is going on smoothly without any jump. So, and also in between this interval here there is no stoppage, there is no break in between. So even though this is a discontinuous graph as a whole, but if we restrict the interval here, for this particular interval this is continuous, and for this particular interval also this is continuous. Now it is discontinuous for these points. At these points, here there are many points, for these points it is discontinuous. So we have to understand that discontinuity may be of a function may be for some points, may not be for the whole domain. Here we have many points in the domain, that is in the x-axis. So the discontinuity is not for all the points in the domain, but for few points in the domain. So that we have to understand. And let us take an example. This is just a random function let's take an example of a function which is defined clearly. If x 0 2, if x is greater than 2. So here we have a function fx equal to 1 if x is less than or equal to 0, and is equal to 2 if x is greater than 0. Now let us draw the graph of this function roughly. This is the origin: 0 1 2 1 minus 1 minus 2, and here we have 1 2. So for every point x less than or equal to 0, for every point x less than or equal to 0, that means for 0 and all the points less than 0, the value of fx is 1. That means at 0 it is 1, at this point it is 1, here also if you take any point it is 1. So for every point less than 0 it is 1. So the function will be like this, the graph will be like this. So for every point less than or equal to 0, the graph is this. For it goes on. And for x greater than 0, that means x greater than 0, we have many real numbers between 0 and 1. X greater than 0 means it will be 0, just x greater than 0, it may be 0.000001. In this way, slightly greater than 0. For every point greater than 0, the value is 2. So here we have points like 0.00001. So for all these points it is 2, but for 0 it is not 2. So here we start from here, or to draw it we write it like this: we put a knot in 0. That means for 0 it is not 2, but for other values greater than 0 it is 2. So for 1 it is 2, for 2 it is 2, for 3 it is 2, and so on. For every point greater than 0 it is 2. Now we see that this is the graph of this function. Now here the function is defined for two intervals from less than 0 and greater than 0. So at 0 the function is changing. Okay, we have to notice that. So what is how is the graph? We draw it like this with a pen. We stop it here and we have to move to this point. So we have to lift the pen. We can't draw it at one go. We have to lift the pen. We come here and draw again this. So clearly this is not continuous. This is not continuous because there is a jump from 1 to 2. When the value of x is greater than 0, then the point fx jumps from 1 to 2. So this is clearly a discontinuous function or not continuous. So just by seeing a graph we can tell that it is continuous or discontinuous. So every time we cannot draw graphs, it becomes difficult. So we have a very formal definition of continuity. Continuity of a point. Now here we see that it is discontinuous at 0. So since the function is breaking at the point 0, it is not continuous at x equal to 0. For other points, if we take the interval from less than 0, if the function was defined from here to here, then it is continuous. Also here from this point to here it is continuous, but at point x equal to 0 it is discontinuous. This we have to understand. Now let us see the definition of continuity at a point. So continuity point, let us see from a textbook. A real function fx is said to be continuous at a point A of its domain if limit of x tends to A fx exists. We have already learned limit in our class 11, and equals f of A. That means the limit of fx when x tends to A must exist, and it must be equal to f of A. Thus f of x is continuous at x equal to A if this is the right hand limit equal to left hand limit equal to f of A. That is the value of the function at A. If fx is not continuous at a point, it is said to be discontinuous at that point. Again, we have fx is discontinuous at A in each of the following cases. Number one is if the function is not defined at the point A, and if the limit does not exist at that point A, and if the limit is not equal to the function at that point. So these are the definition and condition for a function to be continuous. Now let us understand what is left hand limit, what is right hand limit. Okay,